All right, first step we got to do is predict our products. So for the most part, notice I said most part, not all the time. So it's most of the time, guys, you're going to have double replacement reactions. Okay? You could have something else, but those are rarer occasions. All right, so double replacement reactions, we're going to switch our partners up. So when I go through and write out my balanced equation, I got, nope, I need to change that. Definitely will run out of space then. All right, so we've got K2S plus aluminum nitrate yields what? What are my two products going to be? KNO3, potassium nitrate, and S3Al2 is incorrect.
Al2.
Aluminum sulfide, it's Al2, S3. Why is it Al2, S3, and not S3Al2? Metal goes first, guys, which really, not just metal, it's the cation. The cation always goes first, and that's review. All right. But again, how did we get the subscripts there? Because we did the crisscross method. So let's go through and balance it. Well, I've got two K's on the left, and we've got 2 on the right. All right, so that's balanced. I have 3 NO3s, though. So, folks, it's a little bit more complex than that. Your final, when you go through and balance it, what's that? 3, 2, 6, 1 is what you should have for it when you balance it. Now, after it's balanced, what's our next step in these net ionic equation process? Before we can split them up, we have to states of matter, guys. We have to have our states of matter. Before we can do the complete ionic equation, our CIE, we have to look at our states of matter because that's what's going to tell us which ones we can break up or not. So, K2S, is that soluble or insoluble? That's soluble. Because remember, guys, group 1 salts. Anytime you have a group 1 element, it's always soluble. Potassium falls into that. So this is aqueous. Nitrates. All nitrates are soluble. So that means this one's going to be soluble as well. Again, if you're confused, go back and look at your solubility rules. All right, which we have right here. Nitrates, they're all soluble. Sulfide is over here except for group 1. All right. Now, aluminum sulfide, if we go back here, aluminum is not one of the exceptions. It's not group 1, it's not group 2, it's not ammonium. Therefore, this is going to be a solid. So, guys, that is our B equation. B is just our balanced equation. Our next equation we've got to write is our CIE. And what does CIE stand for again? Complete ionic. What does complete mean? All. Ionic refers to ions. So we're going to show all the ions here. This example, I'm glad this is our next one. This one has something interesting. Let's see if you guys picked up on it. So I'm going to split up my compounds. Can I split up potassium sulfide? Yes, how can I? How do I know I can? It's aqueous. Now, guys, one thing, just as a little side note, where we see aqueous, what that means is it's that compound plus what? Water, guys. So even though water's not shown here, because it has the aqueous state of matter, it's saying that, okay, we had potassium sulfide as a solid. We mixed it with water to make a solution. Therefore, we have that compound. That's why it's aqueous, because it's mixed with water. There's our mixture, those two compounds, water and K2S. So I've got potassium. Charge on that is +1. Aqueous. How many do I have? Why is it 6? Right, guys. This is something we didn't see yesterday. We alluded to it, but we didn't see it. But this 2 comes out to be a coefficient, which we saw yesterday. But now we have a coefficient out there, so we have to multiply this. And that is review, because when we balanced equations back in our reactions unit, we said, oh, this distributes in, it's the same thing. Right? Because we can't have a subscript number and a charge together, so we take it out to be a coefficient, so we have 6 potassium ions plus how many sulfide ions? So S2 minus, aqueous, and there's 3 of those. Plus, can I split up aluminum nitrate? Why can't I? Because it's aqueous, thank you. So we have 2 aluminum ions, which is a 3+ charge, aqueous, plus how many nitrates? 6. Again, we take the 3, it comes out, the 2 is multiplied by it, so it's 6 nitrate ions, aqueous, yields. We have 6 potassium ions on the right, plus 6 nitrates. Can I break up aluminum sulfide? Why not? Is solid the only thing I don't break up? No. What else? Liquid and gas as well, guys. You only can break up aqueous. Any other state of matter you're going to keep together. All right, in our last step now, we can write our net ionic equation. But what do we have to take out first before our net ionic? Spectator ions, the ones that stay the same. So is potassium ion a spectator ion? Yes, because it's exactly the same on both sides. 6K plus aqueous on the left, 6K plus aqueous on the right. Is the sulfide ion the same? No, so what do we do with that? Keep it. Aluminum. Will we keep or get rid of? Keep. Nitrate. Slash it, guys. Anytime you see nitrate, it's going to be gone because nitrates are always soluble. And then our last step here is to write down everything else we have to write our net ionics. So we get 3 sulfide ions plus 2 aluminum ions yields Al2S3 solid. So here we go. My balanced equation is the first one. All right, so we got barium nitrate plus sodium sulfate yields, it's going to be, who's going to go with who? Right, so it's going to be barium sulfate, all right, BaSO4, plus sodium nitrate, NaNO3. So we know that all nitrate compounds, guys, are aqueous. So I'm going to add that in there. So this is aqueous over here. All group 1 salts are aqueous, so that means sodium sulfate is also going to be. Now, barium sulfate, if we look at our solubility rules, sulfates, they are always soluble unless, oh, there's barium. So that makes this one what? Solid. Is this balanced? No, so I need a 2 right here. Okay, I need a 2 right there. Now I can go through and do my complete ionic. So I can break it apart. Ba 2 plus aqueous plus 2 nitrate ions aqueous. Why can I break that up again? Because it's aqueous, right? It's soluble. Plus 2 Na plus aqueous plus sulfate yields barium sulfate, which is solid. We're going to keep that together. Plus 2 Na plus aqueous plus 2 nitrate aqueous. All right. And our last one is our net ionic. Cancel out my spectator ions. Barium changes. We're going to leave it. Nitrate. We see 2 nitrates on the left, 2 on the right. We're going to cross those out. Sodium. I see 2 on the left, 2 on the right. They're gone. Sulfate changes, so I'm going to keep that the same. And my final reaction, my net ionic, is going to be barium 2 plus aqueous plus sulfate 2 minus aqueous yields barium sulfate solid. All right, let's say you didn't balance your equation at the beginning. All right, well now when you go through, you have only 2 ions over to the right. Is that the exact same as the left and the right? No, so you wouldn't be able to cancel it out, right? Because you're looking for the exact same coefficient, same charge, same state. Well, if they don't have the same coefficient, you can't cancel them out because they're not spectators. Something's changed. So you've got to make sure that you balance your equation first thing. Otherwise, at the end when you do your net ionic, you may not be able to cancel things out, and you'll think that there's more left beyond there. Questions with this problem? So here we go. Do you have to do any prediction here with this example? No, you don't, right? So this is number 7 again on your notes. All right. They give you everything. You just got to go from the names to the formulas, guys. This should be easy. Go ahead and write out your reaction, balance it, and figure out your states of matter right now. There's our balanced equation. We can split them up. All right, so I'm going to start doing that. Check your work. My bad there. Alright, so there's our complete ionic equation showing all the ions. After we have our complete ionic equation, folks, what can we do now? Cross out our what? Spectator ions. So let's go one by one. 2H plus aqueous, can I get rid of that? Absolutely, it's here and here. Sulfate, can I get rid of that? Here and here. Sodium, here and here. And then chloride. Oh my gosh, what did I just do? Oh, I got rid of everything. Oh no. Oh my goodness. Can we do that? Yeah, guys, we can do that. What's it called? All right, everything is soluble. When you get an example like this, now, let's be honest. Do you think I'm going to give you a lot like this on your test? No. All right, folks, what we write for our net ionic equations, we do this. We say no net reaction. RxN is just me abbreviating reaction. All right, if you don't remember that. Folks, this is where you take two soluble substances, two soluble solutions, you mix them together, and no precipitate forms. It happens, okay? It does. It's not a big deal, but it's rare, right? Especially when I say rare, it's going to be rare with our examples because, let's be honest, that's too easy. That's too easy. You guys have to go through, look at it right, okay? If you get everything where it's soluble, go back and double check to make sure that you have your solubility rules done correctly. Now, guys, if you go back and double check and you get them that they're all soluble, it's okay. It can happen. I wanted to show you an example so you don't freak out when you see one that you come across. But I'm saying it's going to be like maybe 10 or 20% of the time you're going to see a reaction like this. Because again, I want you to go through that whole process to write the full net ionic equation. Questions here with this? All right, what we're going to do with the last part of class, it's a practice time.